Hey guys, Ms. Gosling here. In this video, you are going to learn about the relationship between F equals ma, forces, and kinematics, our previous unit. So by the end of the video, you'll be able to use F equals ma and the kinematics equations to solve two-step problems. So when I say two-step problems, that means you are going to have to use the guess method 2 times. So let's run through a quick review of kinematics. First, I want to run through our 4 equations: v equals u plus at, s equals ut plus 1/2 at squared, v squared equals u squared plus 2as, and s equals u plus v over 2 times t. That was very fast. Just a reminder, v is our final velocity, u is our initial velocity, a is our acceleration, t is the time that all of this all takes, and s is our displacement. Now I want to run through a couple of other quick review things about kinematics. First, the strategy for figuring out whether you're looking at displacement, velocity, acceleration, or time is to use your units. So use your units to determine whether a given number is s, or an initial or final velocity, acceleration, or time. For example, if I see something that is measured in meters, so for example 2 meters, I know that that must be s. If this was given in meters per second, then instead of having s, I would have either u or v. The second thing I want to remind you of is some helpful words that might help you figure out, that might be clues about values for some of your variables. So for example, if you see the words rest, stop, or halt, that means that either u or v, whichever variable that term goes with, whether it's our initial or our final, the beginning of our story, the end of our story, will be equal to 0. So if something starts from rest, our initial velocity is 0. If it comes to a halt, our final velocity is 0, and so on. The last thing I want to remind you of is to fill out your Suva table and use whatever value you might be missing to figure out the correct equation to use. So if time is missing, then I want to find my equation that doesn't have time, and I'll know that that is the equation I can use to solve my problem. So that is our quick review of kinematics. If you need additional review into kinematics, please go back to Unit 2 to get some extra help, so that way you can help remind yourself of some of the material you maybe have forgotten. All those videos are still on Classroom, and you're welcome to watch them. So what does all this have to do with FNet? After all, this is our forces unit, not our kinematics unit. Well, we can use F equals ma to figure out our acceleration, and then we can put that acceleration into our Suva table. So we can use FNet equals ma to figure out one piece of our Suva table, and from there we can move forward to the kinematics equations. Similarly, it may be that we have enough things in our Suva table to calculate our acceleration, and we can then use that information to solve for either our mass or our net force. This sounds a little esoteric, but it's not as convoluted as it might sound. The first thing that I want you to do when you solve one of these problems is figure out, what am I trying to find? If I'm trying to find FNet or m, then I know that I'm going to start with my kinematics. So start with my Suva table, find my acceleration, solve for FNet or m. If, on the other hand, I'm trying to find S, excuse me, I'm going to pick a different color for this one, guys. If I'm trying to find S, U, V, or T, then I know that I need to start with F net equals MA, find A, and then solve with Suva. So I kind of have, so no matter what I do, I'm going to start by finding acceleration, and that's going to depend on what I'm trying to find. So again, I know this sounds convoluted. Let's go ahead and go through some example problems to help you get a sense of what this looks like. So let's go ahead and try example 1. I throw a 34 Newton ball at a wall 101 meters away. If it started at 67.1 meters per second and then stopped when it hit the wall, what is the force the wall was hit with? So I can tell reading this that my unknown is force, since I am being asked to find the force. So that means, looking at the two ways that we can solve these problems that I went over in the last slide, I'm going to have to follow the red method, because I am being asked to find force. That means I need to start by filling out a Suva table. So I know that my displacement is 101 meters, and I know that because my units are in meters for this problem. I know that my initial velocity started is 67.1 meters per second, and I know this again because my units tell me that I'm in meters per second, and we are using the word started here. So that means that it's initial, the beginning of my story rather than the end. Then the ball stopped when it hit the wall. And here, that word stopped is one of my key words, right? And that tells me that my final velocity is 0. Now, this question doesn't tell me what in my Suva table I'm trying to find, but I can use my flowchart for that. So I know that I have to start with my Suva, and I'm using it to find my acceleration. So that means that my unknown has to be acceleration. And that's again from that step in the flowchart. So that means that time is my extraneous variable. And going back to my kinematics equations, that means that the equation I'm going to use is my equation is going to be v squared equals u squared plus 2as. Plugging in my numbers, I know that v is 0 and that u is 67.1. And I'm going to add to that 2 times my acceleration, which is my unknown, so that can stay as a variable, times my displacement, which is 101. When I simplify that, what I'll find is that 0 is equal to 4,502 plus 202 times A. Next, I'm going to need to subtract 4,502 from both sides. And what that'll get me is that negative 4,502 is equal to 202 times my acceleration. Dividing both sides by 202, I get that my acceleration is negative 22.3 meters per second squared. So I've started with my input and I found A. Now I need to use F net equals MA to figure out my net force. So I have finished step 1 and I'm moving on to step 2. At this point, I now know that my acceleration is negative 22.3 meters per second squared. And I know that my mass is equal to 34 divided by 9.8. Why is that, you might say? Note that instead of being given the mass of the ball, I'm given the weight of the ball. So if ever I'm given if I'm given my weight instead of my mass, I need to divide that number by 9.8 in order to figure out my mass. I know whenever I see that newtons instead of kilograms, that's when I need to divide by 9.8. So that means that my mass is 34 divided by 9.8, or 3.47 kilograms. And I'm ready to move forward to my unknown. And again, I know that my unknown must be force, since that is what I've been asked to find. So moving forward, I know that the equation that I need to use for this problem is F equals ma. And I'm ready now to sub and solve. So my force is what I'm trying to find, so we can say it's a variable. My mass is 3.47, and my acceleration is negative 22.3. When I plug that into a calculator, I get that the force that the wall is hit with is negative 77.4 newtons. And there you go. That is the answer to your question, or to this problem. And again, just walking through the process, I started with my Suva. I used that to find my acceleration, and then I used my acceleration to solve for my net force. I did have to have one extra trick in there, and that is turning my weight into my mass using the equation W equals mg, or W equals 9.8 times my mass. Let's go ahead and move forward to another example. So let's go ahead and start with one more example. Ruth hits a wall with an 80 Newton kick. The kick takes 0.21 seconds, and her 7.17 kilogram foot comes to a halt after hitting the wall. What is the initial velocity of her foot? So in this question, I am being asked to find u, my initial velocity. So that means I'm going to have to follow my green process. So I'm going to start with F equals ma, find acceleration, and then solve the Suva table. So let's go ahead and get started with step 1. F equals ma. So I know that F net is equal to ma. I know that my force. So let's go ahead and pause for a moment. I want to back up. And I want to start by actually listing out my givens. We know we're using F equals ma, but I do want to follow the correct process here. So I know that my force is 80 newtons, and I know this because I see that the units there with the force that I'm hitting the wall with. I also know that the mass of her foot is 0.17 kilograms, since I can see the units there for her foot. And I know that my unknown here must be acceleration, since that is what I have to find according to my roadmap over here. So that means that my equation is going to be F equals ma, force equals mass times acceleration. So when I sub and solve, I can plug in my force, which is 80, my mass, which is 0.17, and leave acceleration as a variable, since that is what I am trying to find. When I do that, and so to finish solving this, what I'm going to need to do is divide both sides by 0.17 to get a by itself. And when I do that, I will find that my acceleration is 471 meters per second squared. Now I'm ready for so now I have used F equals ma to find my acceleration, and now I'm ready to move on to step 2, which is to use a Suva table. So for my Suva table, I'm going to go ahead and line up my unknowns and my givens. So I know that my acceleration is 471 meters per second squared, so I just solved for that. I know that the time that it takes my kick to happen is 0.21 seconds, and I know that because the units for next to 0.21 are my units for time. And I know that her foot comes to a halt when she hits the wall. And what I'm gonna have to do is figure out the initial velocity of her foot. Now, one thing here that I want to change, I know that she's slowing down, not speeding up, right? Because she's going from moving to not moving. So that means that her acceleration needs to be negative. So instead of writing positive 471, I actually need to write negative 471 meters per second squared. And I know that that negative sign is going to come from the fact that we are slowing down. One hint that you will have for this when you're solving these problems on your own is that if our final velocity is 0, our acceleration is almost definitely going to be negative. Anyhow, my unknown is my initial velocity, since that's what the question is asking me to find, and that means that s is my extraneous variable. From this, I can figure out what my equation is, and looking at my 4 kinematics equations, the only one without displacement is v equals u plus at. Plugging in my numbers, 0, and moving on to my sub and solve stage, what I'll find is that 0 is equal to u, or my unknown, which I can keep as its as a variable, plus negative 471 times 0.21. When I solve that out, what I'll get is that 0 is equal to u minus 98.8, adding 98.8 to each side. I find that u is equal to 98.8 meters per second. And there you have it, guys. That is the solution to this problem. So moving forward, I do want to wrap this up with takeaways since it's been a very long example video. So takeaways, we can solve kinematics problems using F equals ma. We can find F net using kinematics. And all these problems are 2-step equations. So you have to follow that flowchart and either start with Suva and then find A and then use that to find to solve an F equals ma problem, or you need to use your F equals ma to find your acceleration and then solve a Suva problem. Regardless, step number 1 is going to be find your acceleration. With that, I'm going to let you guys try some of these problems on your own. Best of luck and happy solving.